So as I mentioned in the previous video, we will solve minimization problems, standard mins, by applying the simplex method. But what we'll apply the simplex method to is the dual maximization problem. While the max of our W will be the same as the min of the Z, we won't be able to find the X's in the standard way. What will actually happen is we'll let the slack variables be our X variables. And so we may have slacks like X1, X2, and X3, and then we'll read our solution from the bottom row. So it'll be a little different than what we did before. So what we'll do is we'll go through the example we set up in the other video, and we'll actually solve this using the dual. And so let me remind you of what we had when we set this up. We found the dual to this to be maximize W, and remember it's all going to be Y variables now, so 20Y1 plus 30Y2, and then subject to, and all of these came from that A transpose, right? So we ended up with more constraints, but less variables. And notice that the problem that we set up ended up being a standard max. That's why we can apply the simplex method to this. And so what we want to do now is actually set up our simplex tableau. And so we're going to have columns for Y1, Y2, but now notice we have 3 constraints, right? So this means we need 3 slack variables, but we'll call those X's. That'll be X1, X2, and X3. And then we have our column for W. And so my first constraint will give me a 2, 4, 1, 0, 0, 0, 40. My second constraint will give me a 1, 1, 0, 1, 0, 0, 12. And my third constraint will give me 5, 1, 0, 0, 1, 0, 400. So I'm skipping a little bit of steps from before, assuming you know X1 is the slack variable for the first constraint, X2 is the slack variable for the second. In other words, I skipped writing the equations. You can decide to write those out or not. It'll be just like you did before. Now finally, I need to rewrite my objective function. So remember, I bring everything to the same side. I end up with minus 20, minus 30, 0, 0, 0, 1, 0. So this is my initial tableau. So notice, if we read the original or the initial tableau, any solutions we get from the usual way will be y1 equals y2 equals, right? So now what we want to do is do regular simplex to this tableau. And so we'll go through the usual steps. And so here's my tableau again. And so what I'm going to do is actually describe to you the steps to go through this. Of course, I want to pick where I'm going to pivot, right? So just as a reminder, so I'm going to pivot in this column because it has the biggest negative. And then I'm going to pick the smallest value when you divide. And so this would be 40 over 4, which would be 10. This is 12 over 1, which of course is 12. And this is 400 over 1. That's definitely too big, which is 400. So we'll be pivoting on the 4, right? And so that pivot would require multiplying by a fourth and then subtracting. I'm going to skip some of that and go ahead and see what happens. And so let me get rid of this, bring it up. And so my first pivot, I pivoted on that 4, and this is where I end up, right? But I'm not done because we still have that negative 5 there. I'm assuming you can go through the steps to pivot, but I need to pivot in that first column. And this is regular simplex, so I pivot and I end up with this final tableau. Now this final tableau is something we need to talk about. And so let's remember what these columns were. So I know I have my final tableau because we have no more negatives down here. But now I got to remember that we had a y1 and a y2, and then we had 3 slacks. The solution y1 equals 4, because that's where that 1 is in that unit column, y2 equals 8, are the values of y1 and y2 that maximize w to get 320, but that isn't what we're interested in. We're interested in what values of x minimize z, right? So it turns out that this will be the min for z. It's the max of w, but it's also the min of z. So we have a min of z equals 320. The question is, at what point? So that's why we picked our slack variables this way. This is actually your solution right here. x1 is 5, x2 is 10, x3 is 0. So we don't go too much into the theory about that. Again, it's an interesting read, but for our procedure, you have to remember when you're using the dual, your answer actually will be down in the bottom of the tableau. So we have it at 5, 10, 0. So again, I didn't go through in detail the steps here once we had our Tableau because this was simplex. Same thing we did in the previous week. Instead, the focus is on how is it different once I get the solution, and that's what you should focus on. Knowing how to write the dual, and then knowing how to read the solution from the final Tableau.